Hi everyone. So this is the video for section G, which is measuring the spread. So in the last video, or actually I guess 2 videos ago, we talked about measuring the center. And we talked about 3 different measures for that, the mean, the median, and the mode. So they were sort of designed to give you one number that represents sort of a middle of the road in 3 sort of slightly different ways, but a middle kind of value to represent what's in the middle of this data set. Measuring the spread is a little bit differently. It's looking at measuring sort of the larger scale of things, like how far apart are our data values, how spread out are our data values. And so we're going to look at a few different measures to do that. We're going to look at range, we're going to look at upper and lower quartiles, and we're going to look at the interquartile range. So I think the easiest way to go about doing this is just to kind of run through an example, and we'll show you how to find each of those things and sort of talk about what they are and what they mean. So we started with this set of values, just a random generated set of, let's say it was a score on a math test and the math test was out of 10. Let's imagine. Okay, so here are all the scores for the students that wrote this test. So the first thing you need to do when you're doing any of these sorts of measures is you need to put the data in order. And so all I've done is I've taken the 2 and I've put it there, and then I saw that we had 1, 2, 3 3s, so we got 3 3s. So just ordering the data, that is step 1. You have to do that when you're finding the range, the quartiles, interquartile range, or even median for that matter. You have to make sure that all of your data is in order. So the first measure, the first sort of statistic that we're going to talk about is range. And so range is one of those words that's really popular in sort of common language, but it has a very specific meaning in math. So oftentimes you would hear the range is from 2 to 9. Yes, except that's not exactly right when it comes to math. When you're finding the range in math, you are finding the maximum minus the minimum. So it is a single value. It is not the data goes from here to here. The range in this case, my maximum value is 9. My minimum value is 2. So the range of this data set is 7. It is not 2 to 9. It is 7. Okay, so that's range. So range is maximum minus minimum. Away we go. So the second thing we're going to find is the median. And I know it's not one of the measures that we talked about here, but in order to find the upper and lower quartiles, you need to know the median. The median is your starting point when you're doing any work with quartiles. So median, n plus 1 divided by 2. I have 15 data points here. So I'm going to do 15 plus 1 divided by 2. That gives me 16 divided by 2. So the 8th value is my median. 1, 2, 3, 4, 5, 6, 7, 8. So this 5 right there is my median. So the median divides the data exactly in half. So 50% of the values fall above the median, 50% of the values fall below the median. So the median is like the middle value. And in this case, it is an actual value. So then we move on to the quartiles. So the upper and the lower quartiles are found in exactly the same way, just on one side of the median versus the other. So let's start with the lower quartile. You will often see this referred to as Q1. So Q1 represents the 25% mark. So it is essentially the median of the lower half of the values. So we found the median of the entire data set, and that cut ourselves 50%, 50%, exactly in half. Now we're going to look only at the data values below the median, and we're going to find the median of those. That's going to cut this in half, which will make 25% and 25%. So Q1 is the 25% mark. So we're going to, again, do n plus 1 divided by 2. But now, since our median was an actual data point, we are not going to count that one. So now we're dealing with 1, 2, 3, 4, 5, 6, 7 values. So I've got 7 plus 1 divided by 2, so that gives me 8 divided by 2. So the 4th value is Q1. It is my lower quartile. 1, 2, 3, 4. So this is Q1, and I'll even mark this one in as median. So Q1 is equal to 3. The lower quartile is 3. Then if we move on to the upper quartile, I know you might be thinking, I bet that's called Q2. Not exactly. It's called Q3. And that's because the median is technically Q2. It is the second quarter. So if this represents the first quarter, the first 25% of the values in the data set fall below Q1, then the next 25% are between Q1 and the median. That would make the median Q2. And then we're going to find the median of the data points above the median. So again, n plus 1 divided by 2. We don't count the median because that was an actual data point. So we've got 1, 2, 3, 4, 5, 6, 7 values there. 7 plus 1 divided by 2. So that gives us, again, the fourth value above the median. So 1, 2, 3, 4. So that 7 is Q3. So again, range is 7, 9 minus 2. Median is 5, the 8th value. So we found the 8th value. Q1 is the median of the values below the median. So that was our 4th value. Upper quartile is the median of the values above the median. So that was 7. So the very last thing we have to figure out is IQR, interquartile range. And so the interquartile range is Q3 minus Q1. So again, it is not a range as in it goes from 3 to 7. It is 7, which was Q3, minus 3, which was Q1. So the IQR is equal to 4. So the range between the quartiles is 4. The range of the entire data set is 7, because our lowest value is 2, our highest value is 9, so 9 minus 2 gives us a range of 7. The interquartile range is the range between the quartiles. So if you think about it like this, you've got a minimum value, you've got Q1, you've got the median, you've got Q3, and you've got the maximum. In between here is 25% of the data. In between here, 25% of the data. So if you go from the minimum value all the way to the median, that gives you 50% of the values fall there. Then again, we've got 25% here, 25% there, and then from the median all the way to the maximum, we have another 50% there. So the interesting thing is the IQR going from Q1 to Q3 also represents 50% of the data. So 50% of the data fall in between Q1 and Q3, 25% are below, 25% are above. Ta-da! This sort of idea is going to become really important when we get into our next section on box and whisker plots. All right, there you go.